Limitations of Bohr theory. First, according to Bohr, the radiation results when an electron jumps from one energy level to another energy level. But how this radiation occurs is not explained by Bohr. Bohr's theory has successfully explained the observed spectra for hydrogen atom and hydrogen-like ions, example He sub plus Li sub plus 2 Be sub plus 3 etc. It cannot explain the spectral series for the atoms having a large number of electrons. Next, Bohr's theory even fails to explain the splitting of a spectral line under the influence of magnetic, Zeeman's effect and electric field, Stark effect, as a line in emission spectrum splits off into closely packed several lines. Some deduction from the theory did not agree with observed facts. Next, Bohr assumes that an electron in an atom located at a definite distance from the nucleus and is revolving around it with definite velocity, that is, it is associated with a fixed value of momentum. This is against the Heisenberg's uncertainty principle. Next, there was no satisfactory justification for the assumption that the electron can rotate only in those orbits in which the angular momentum of the electron, that is MVR, is a whole number multiple of h by 2 pi. That is, he could not give any explanation for using the principle of quantization of angular momentum, and it was introduced by him arbitrarily. Now we see Bohr-Bury scheme for electron fill-up in cell. First, Bohr-Bury scheme. First, the maximum number of electrons in any orbit is given by 2 into n square, where n is the cell number. So, for k orbit, whose orbit number is 1, maximum number of electrons 2 into 1 square equals to 2. So, in k orbit 2 electrons remain. In L orbit, whose orbit number is 2, maximum number of electrons 2 into 2 square equals to 8. So, in L orbit 8 electrons will remain. In M, for orbit M, orbit number is 3. So, maximum number of electrons 2 into 3 square 18. And for orbit N, orbit number is 4, maximum number of electrons 2 into 4 square 32. Second, the outermost cell in an atom shall not have more than 8 electrons and the penultimate cell not have more than 18 electrons. Penultimate cell is the cell just before the outermost cell, is called penultimate cell. Third, it is not necessary for an orbit to be completed before other commence to be formed. In fact, a new orbit begins when the outermost orbit attains 8 electrons. And fourth, the outermost orbit cannot have more than 2 electrons and the penultimate orbit cannot have more than 18 electrons, so long as the next inner orbit in each has not received the maximum number of electrons as required by rules 1 and 2 previously discussed.